Okay, now I'm on mute, so I can actually talk into Zoom. I'm going to start my introduction over again. Hello, my name is Clemence Yi, and welcome to Introduction to Linux. I'm the director of RBB for Swift, and we have I have slides for this. And then we have our lovely SWINTerns over here. Everybody give the SWINTerns a round of applause. This is Jimmy. Yeah. Before we get started, just a little thing about becoming a paid member. Becoming a paid member gives you a lot of cool perks. You get t-shirts, you get stickers, webcam covers, giveaways, other things. And we also have our mentorship program with other things. It is $20 per one semester or $35 for the entire year. And then I'd like to invite Corinne up to talk about Swift Pals.
Hi everyone. So this year Swift is introducing a new mentorship program. So Swift Pals basically is going to be creating groups among Swift members to either compete in competitions like Typestorm, RBB, NCAE, or just to have some study groups so you guys can like study cyber together, do hackathons, go to your home labs, fun stuff like that. And these groups will be of 45 and will be led by an intern member, so you have a direct point of contact if you have any questions at all. Our EWORD members can also coach you as like in preparation for any competition that you want to do. So if this interests you at all, you go ahead and fill out our interest form. We are going to be holding interviews in person just to kind of get a sense of like your personality, your vibes, so we can match you with other people that kind of are like same personality and same interests. And so you can also match an EWORD member with you. If you have any questions, feel free to ask me or Jacob on Discord or after the meeting as well. Thank you.
Thanks, Karina. Now I'd like to invite Jasmine up to talk about CSAP.
Okay, besties. So in October, on October 20th, apparently, Cowboy Pomona hosts our very own campus-run cybersecurity and awareness fair, right? So there will be employers, a whole bunch of big brand names that you know and love, and demonstrations from all of your favorite clubs. So go ahead and remember to stop by. There is also 2 different poster contests, right? One of which is really research-oriented, so if you're involved in research with a professor, absolutely hop in on that because there's some pretty big cash prizes, but there's also I want to call it an awareness poster, right? That's more so informational, that just covers really introductory cybersecurity topics, that also has a pretty juicy cash prize. So consider entering those and make sure you stop by and see our demo. There is also a job fair later that evening, so make sure you guys have your resumes prepped and go ahead and stop by.
Thank you, Jasmine. Alrighty, let's get into the wonderful topic of Linux after I talk about this schedule, which I completely forgot was here. So as you can see, we're on the Intro to Linux, and then we'll have our workshop this Friday. We have some pretty cool stuff planned for you. So today we're going to be covering, first of all, not only what is Linux, but we're going to also talk about Bash, Filesystem, and users and permissions. Now, what is Linux? Before we can answer that question, we have to ask, what is an operating system? Anybody want to give it a try? Sure, I mean, it's kind of in the name. Oh, what's it actually showing? Okay. Basically, an operating system is a special set of software that allows your hardware to communicate with all of your applications. As you can see here, we have kind of different layers of your computer system. You have your hardware, which, for example, is a laptop. You have the kernel, which interfaces with that hardware and talks to the rest of the system. Then you have the OS that wraps around that kernel and provides a lot of the kind of software definitions. And then you have the applications which run on that OS. And that's what we basically see every single day. Linux is another operating system in comparison to something like Windows or Mac OS. What makes Linux special, however, is that it is open source. Open source means that it is free and open for everyone to use without any commercialization penalties. The only thing that they require is for you to accredit them with the credit the creators whenever you want to use it in some kind of commercial or public factor. It is based on what is known as the Linux kernel, which is separate from something like the Windows kernel, which I believe is Windows NT, and the macOS kernel, which I actually don't know what that is. But Linux is not released in something like Windows 2019, Windows Server 2019, or Windows 10, or macOS, whatever version we're on currently. Linux is released in separate distributions, commonly known as distros. The most common ones you'll find are Debian, CentOS, Ubuntu, Red Hat, and there's literally hundreds of distributions. The Linux kernel. Think of popcorn. With popcorn, you have a kernel and you have a shell. That shell wraps around the kernel and it kind of protects it. It's very similar with Linux. With Linux, the kernel directly talks to your processor, memory, disks, devices, everything in your computer. But then, how does the software talk with the kernel? That's what the shell is for. Through the shell, you can talk to the kernel. The kernel is one of the most critical and core parts of an OS, and without it, it literally won't work. Now, we have to talk about two major types of distributions for Linux. We have Debian-based, and we have Red Hat-based. Debian is a fully open source version of Linux that is maintained by the community, and some common distributions based off that are Ubuntu and Linux Mint. With Debian, you'll find that a lot of things are, a lot of files end with a .deb, and you'll be using the dpackage and apt package managers. More on that later. For Red Hat is managed by the Red Hat company. I don't know what their ending is. Red Hat basically has a lot of different variants as well. You have CentOS, you have Fedora, and Red Hat uses RPM as their package manager with Yum and DNF for dependency managers. Again, more on that later. Now let's talk about Bash, and we're not talking about having a big fight here. There is something called the terminal, and I'm sure that a lot of us have heard of the scary terminal at some point where you're not allowed to use a GUI, you're not allowed to use your file system explorer or open applications up with a fancy interface. Instead, with the terminal, transcript, right, that exists. A terminal is the main place to do what you want to do on Linux. You can type commands here, and that's where they'll run. We have two forms of terminals. We have the terminal interface, in which you have no GUI, and it's literally just a terminal. I will be showing a demonstration of that momentarily. The second form is a terminal emulator, in which you have a terminal that is on a GUI, but the terminal is not what's actually, it's not what you actually interact with on the daily basis. What the terminal does is it runs a shell, and the most common shell is Bash, which stands for Born Again Shell. You can find this at the file system location bin bash. We will be talking about that a little bit later. But basically just know that whenever you use a terminal in Linux, most of the time it's going to be Bash. We have to talk a little bit about Bash command syntax. Bash commands might look scary, like this. This uses a utility called sed, and sed can be very scary sometimes. However, once you break it down, it's actually extremely simple. You start out with your command, then you go to your options, then you have your arguments. For example, if you look at the sed command that I've put up here, the command is sed. The option is -i, and your arguments are those gigantic strings over there. But once you break it down to that, the commands are actually really simple. And if we go into our other examples, we have ls, we have cd, we have ls command, we have the cd command, and then we have the argument home user 1. We have the ls command with an option la, and then we have the argument user1/downloads. And then we have ls with just the option r. Here are some very simple commands. We have echo, which literally repeats what you tell it. We have less, that lets you open a file and read it in a page, which is extremely useful because if you just dump a whole bunch of text into a terminal editor, you can't just scroll through that. And then you have cat, which dumps a file's contents into the terminal. And to show this off, I have a little demonstration set up. So I'm going to log into my Linux box right here. First of all, you can see that this is a standard GUI. It doesn't look like Windows, but it basically acts exactly like Windows. So what I'm going to do here is I'm going to open a terminal emulator because this is a terminal running on a GUI. Now, I'm going to do an ls command. You're going to learn about that later. But you can see I have a file called banana.txt. I'm going to less banana.txt. You can see that I can read the contents of this file. Now, if I cat banana.txt, it basically just spews it out into your terminal. That's too small, isn't it? Let me make it a little bit bigger. Is that better? Okay. And if I do echo, you can have a little bit of fun with this. You can say, I am Clemence, and it'll print it out. 3 commands at the beginning of your Linux experience. Over here, we have a text-based interface. This is less commonly known as a TUI, but you can see here that I can't click on it because it's literally just a terminal. This is an actual terminal, not a terminal emulator. You can see that the same banana.txt is on here. So I can cat banana.txt, and it spews it all out there. What if I have a larger file that scrolls down? So I'm going to cat /etc/ssh/ssh config. And you can see that it's pretty long and I can't scroll. Like I'm scrolling, I can't scroll. So what you would do is you would do less and then etc ssh config. And now I can scroll through it. Very useful way to open a file and take a look at it. What if you want to edit a file? Well, we have a number of tools for that. The first one we're going to talk about is gedit. Gedit literally means graphical editor. As the name implies, you can use it in a GUI to edit a file. So I'm going to do a gedit and then banana.txt, and bam. It's kind of like Notepad on Windows, and if there's a Mac equivalent, I'm sorry, I don't know it. But I can go in here and can say boom, I can say banana, and I can save it. And if I open it up again, you can see that the changes are saved. Now, unfortunately, you can't use a graphical editor on an interface that doesn't have a GUI, which is where other useful editors come in. We have Nano, which is a very basic editor, but it is quite useful in a pinch. We have Vim, which is a little bit more complicated to learn, but once you get the hang of it, it is actually quite a bit more powerful than Nano. And then you have Vi, which is the older version of Vim. Don't use Vi, always use Vim. Let me give a quick demonstration of that. So I'm going to do nano, ssh config. And you can see that if I actually had write permissions here, I could edit this file. If I do vim banana.txt, I can go through. And if I go into insert mode, I'm not going to go through the intricacies of Vim here, but I can basically edit it. I can add a whole bunch of stuff. And then I can just kind of quit it. Yeah, I'm just going to ignore that. How do I get out of this, Justin? Without writing? Oh, it's exclamation. Thank you. As you can tell, I don't know how to use Vim. Yeah. From there, I'd like to call up Dylan here to talk about the file system. Don't use mine.
So hi guys, so we'll be talking about file system. So you guys actually interact with the file system every single day. So do you guys actually have an idea of what it is? Does anyone want to answer?
Is file system just another word for a directory?
Oh yeah, so this is where you store all your files in, right? So for example, what computer do you have? Operating
This is the one borrowed from the library.
Okay, yeah. So if you have a Windows, right, you go into your drive, and within the drive, you have different folders that hold all of your files, right? So these files can be all the essays you write in Word documents for your macroeconomics class, or images that you took from the last vacation. It all goes into this C drive, right? So there's actually a hierarchy. So the first one is the C drive. It contains everything, right? And then within it, you have folders. So for example, I have a macroeconomics class, and I make a folder for it because I want to put all of my files that have to do with the class into this folder, right? So I have my supply and demand graphs. I put it into this folder. I have my essay about aggregate demand. I put it in there, right? So do you guys understand what a file system is? No? Yeah. So then Linux actually has a file system as well, and it's very similar. So you start in the root directory, right? So that's equivalent to the Windows C drive. So it contains all of your different files that you have. Everyone got it? Yeah. Okay, so this is a more in-depth view of the Linux file system hierarchy. So as you can see, you start from the root directory. You start from the root directory on top, which is equivalent to C drive, as I said before. And then within it are a bunch of different folders, also known as directories, right? So each one of these directories has its own, like, it has its own, what's it called? Operation for the operating system, right? So /bin, /boot, /dev, we'll be talking about these folders later on in the slides. So every Linux operating system has all of these folders installed within it, and this is how they manage all of the data, right? So the /, so this is the root as we talked before. It's the lowest level and everything will be in here, all your files and everything. So it's kind of like the C drive, as I said before, in the Windows. /etc. So this stands for etc. That's how you pronounce it. And all of your configuration files go in here. So does anyone have an idea what a configuration file actually is? Okay, so a configuration file is basically the settings of your program. All your rules go here, right? It's what controls your it's what controls your operations of your system, right? So for example, my program has password authentication. That means that I have to have a password in order to go into the program. So I might go into the configuration file for the program and I might change it to no. So whenever I use the program, I don't have to use a password. I can just enter in. So yeah, configuration files are actually very important because you can change the rules of how it operates and you can even shut it down if you want to, right? So it gives you full power of it. So the /home folder, so all the users' files go here. So all of your personal data, all your pictures that you've taken, all of the essays you've written, it all goes in here. All your personal stuff that you use for yourself, right? So /var, so these are variable data files. So every single program that you have that is continually growing, it has a variable data file, right? So for example, log files, temporary files, databases, and websites. These applications, they continue to grow. It continues to collect data. And when it continues to collect data, it's written inside of these files. You get it? So for example, I have a website, right? And every time someone goes on there, that's a bit of data. Every click, that's data, right? So every little data I collect, it writes into this data file. You guys get it? So any application that is continually growing has one. So /bin, so this is the folder that holds all your binaries, also known as programs. So in order to go through the command line, right, you have to be able to use commands. So that's how you interact with it. So such as commands as cd, which is change directory, that's how you move to a different folder, or ls, it lists the files that you have in the command line. In order to use the commands, you have to have these commands, right? So then it is all stored inside of this folder. And then Clemence will be showing you the commands I just talked about.
Okay, so we have some commands over here. There's 5 on this little list. We have cd, which stands for change directory. And as you will see in Linux, people who make commands, they love to make them very representative of like their full name. CD, change directory. LS for list contents. MV for move something to somewhere else. CP to make a copy of something. And then RM to remove something. So let's go ahead and take a look at these. I'm gonna go back into my GUI and I have to log in again because it's been like 5 minutes, I think. So right now I'm here in my home. And if I do a pwd command, which stands for print working directory, you can see that I'm in home entangled. What if I want to move into my desktop? Well, I'm gonna do cd desktop. Bam, I am suddenly in desktop. And if I do pwd again, you can see that I'm suddenly in my desktop. Now, let's say I want to find what's in here. I've done this before, but let's do ls. Wow, there's a README in here. We should read the README. Does anybody want to suggest a command to open this README to look at it? Sure, we can use cat readme.txt. And what it says is, did you read me? No, did we? Now, let's say I want to move this README somewhere else because I don't like seeing it on my desktop. Then I would use move. So I'm going to move readme.txt to /home/entangled. And if I do an ls command again, you can see that it's disappeared. But if I go back into my home directory, you can see that we suddenly have readme.txt. And just to prove that this is the exact same thing, it's asking again if we read it. Now, let's say I want to make a copy of this README because I really like the README and I want to store it somewhere else. So I'm going to use the copy command. I'm going to copy readme.txt into no.txt. And if I ls, now you can see that I have a no.txt. And if I cat no.txt, no, I didn't read it. Now, let's say I disagree with that statement and I want to remove the no.txt file. That's when the remove command would come in. So then I would do rm no.txt, and if I ls, it's gone. And when you use the command line, there is no recycling bin. So for those of you who are used to just deleting something and then recovering it about 2 seconds later, I'm guilty of that, well, try not to delete things, unless you really need to. All right, and now I'd like to call up Jimmy to talk about users and permissions.
Okay, hello everyone. I'll be going over users and permissions. So who has an idea of what users are? Yeah, so basically anyone, you or me, or we also have system users as well. So the three main categories of users are the root user, normal users like you and me, and system users, as I said before. So going into the root user, this is the all-powerful user, also known as the super user. They could basically do anything on a system. They have all the read, write, and execute permissions as well. And this is usually restricted for system administrators or people that really know what they're doing. They have a UID of 0 as well. So next we have system users, and these users are used to run software or applications, and they have the necessary positions for these applications to like receive data or run these programs. These users have a UID of under 1,000. Yes. So UID is a user ID. It basically identifies the an identification number for these users on a system. So then we have the normal users, which are you and me. These users are what we use to log in and kind of interact with applications and programs with a GUI. These typically have the UIDs of above 1,000. So going into one of the important files for users, we have the PAM files. So PAM stands for Pluggable Authentication Module. And these files basically deal with the authentication or how users log into a system. Let's say you want to switch to the root user from your user really easily. In the PAM files, in one of the configuration files, there's a setting like covered before. It's just like a yes or no option. If you want that setting enabled, you would switch it to yes, save the file, and then you'd be able to log in as root easier. It is also how Linux verifies your passwords and kind of ways passwords are used to authenticate. To create users, we have two main commands. We have the add user command and the user add command. They sound very similar and they could be confusing at first. And for me, I still don't really know the difference without looking at it. But the add user command lets you add users with directories and all their information loaded up with their kind of segmented folders dedicated just for them. And then the user add command adds the user, and that's all. So typically I use the add user command since you would want those extra files and directories to be created for use for the user. There's also deleting user. We only have one command for this. It's called del user. It's very self-explanatory. It just deletes the user and not related to del taco, so don't get it confused. So we have some pretty important user files as well. We have the Etsy password file that basically holds information about the user, like their UID, groups they're in, stuff like that. Then we have the Etsy shadow file, which stores the encrypted user passwords in it. And this file is usually only accessible by the root user. It's not that often that other users have permissions to this file since it's very sensitive. And lastly, we have the Etsy group file. So this stores information and attributes about the groups on the system. So moving on to permissions. Permissions could be kind of complicated to understand on Linux. They use a binary to octal numbering system. If you haven't seen binary before or octal representations, it might be a little confusing. There's this trusty calculator we have. So basically, this kind of simplifies things if you don't want to go through the binary or octal representations. So permissions in Linux are stored in basically three groups of users. So there's the owner of the file, and then there's the group of the file, and then everyone else, everyone else's permissions for the file. So this calculator, basically we could like check permissions we wanted to have. Let's say the user or the owner, we want read or write permissions, then we could check them, and then it calculates the permission for us. But if we want to understand this, yes, if we want to understand this, we have this diagram to the right. So basically, the three main types of permissions are read, write, and execute. So that these read, write, and execute bits are represented by the R, W, and X in the middle column. So if the permission has a 1 in place of the R, then the user has read permissions, and vice versa for the write and execute permissions as well. So we could see these read, write, execute permissions on the top. The user would have full access to the file to do pretty much whatever they want. And this is represented by a 7. So the 7 is the octal representation. So if you're unfamiliar with binary, it could be a little confusing. But to break it down, the first one, the first leftmost one represents a 1, and then the ones kind of double in value. So the second one represents a 2, and then the third one represents a 4. So if the permission is set to all ones, then we know 1 + 2 + 4 is 7, which is the representation in octal. Additionally, there are like I said before, it specifies the owner, group, and everyone else on the system. So usually when you're modifying the permissions of a file, you would specify all these permissions in these 3 octal numbers. So this could be shown with the chmod command and the chown command. So the chmod command changes the permissions of files or folders on a system. And the syntax is basically chmod, the 3 octal numbers, and then the file you want to change the permissions to. Just like that, we have the chown command too, which changes the owner of the file. This syntax is just chown, the owner of the file, and then the file. So yeah, that's permissions.
Before we go on, I am actually going to demonstrate those. Before we go on, I am going to demonstrate these quickly. So let's say I want to make a user on my computer. I'm gonna volunteer Jimmy. So I'm going to add user Jimmy, and I have to enter my password there. I'm going to give you a password of hi. Your full name is Jimmy. Your room number is 0. Your work phone number is 0. Your home phone number is 0. Your other is 0. This is correct information. So now, if we /etsy/password, what does Etsy password do? Anyone? That's what you would think. However, what Etsy password actually does is show all the users. It sounds weird, but you'll get used to it. If we go in here, we can see that, first of all, we've defined the root user up there, and we have a whole bunch of other system users over here. But if we go down, we will eventually see Jimmy. Jimmy is a user with an ID of 1001, and his home is /home/Jimmy. So if I go to /home, and if I ls, wow, there's a Jimmy here. So if I sudo su Jimmy, okay, now I'm logged in as Jimmy, and yeah, you can see that Jimmy has nothing here. If I ls-la, which stands for basically listing everything possible, you can see that there's a number of hidden files here, but also we can see some permissions here. Can anybody tell me what this first permission does down here for doc profile? It says rw-r-r-. What does that mean? Mm-hmm. Yep. Exactly. Now let's say I want to create another file. So I'm going to touch is a command to just create a blank file. So I'm going to touch banana.txt here. And if we ls, we can see we have banana.txt. Now if I ls-la banana.txt, we can see it has rw-rw-r-, which means exactly. So let's say we want to give everybody the ability to write to this file. Then what I would do is, and I don't know these permissions off the top of my head sometimes, chmod, I would do 666, because 666 would mean read and write permissions for everybody. And I'm going to set that to banana.txt. Now, if I ls-la for banana.txt again, we can see that the permissions have changed. Where it once was that everybody could only read it, now everybody can write to it. So let's exit out of Jimmy and let's exit out of Jimmy's shell and let's nano into that banana text file. I'm gonna nano /home/Jimmy/banana .txt. And this is due to another problem where Jimmy's home folder is not accessible to me. But I need a different demonstration for that. Let's go into Etsy. You can see that there's a whole bunch of files here. Let me do that again. All of these are configuration files. There's definitely a lot of them, and most of the time you won't have to deal with like 80% of these. But let's say that I want to go into the password file and I want to change Jimmy's shell. So if I do nano/etsy/password, it says that it's unwritable. We saw this issue before. So let's ls-la etsy password. You can see that the owner is root, and root can read and write to it, cannot execute. Everybody in the root group can read it, and everybody else can also only read it. But I'm not root. So I'm going to temporarily steal some root permissions with sudo to run the chmod command. This is bad practice, by the way. Do not do what I'm about to do. I'm going to set 666 to Etsy password. Again, this is very bad. Do not do this, please. If I ls-la Etsy password, you can see that everybody can now write to this file. Now, this is a bad thing because it means anybody can change their ID number. You can change your shell. You can change where your home directory is. You can change literally everything about your user. With that, you could basically make yourself a super user. So if I just nano Etsy password now, well, I don't have permissions to write in Etsy, so I'm just going to chmod for Etsy. But if I nano Etsy password, what? Okay, so I broke my system. Let's go into here. No, wait, that's file. Once again, I can't write to this. If I go into super user, and if I enter my super user password, you can see that now I can edit this file. So Jimmy's not on this one. So let's add Jimmy's user. And I'm going to do user add, so it just creates the user without adding anything else, just for the time's sake. And then let's say that I go into Etsy password one more time. Now, if I go all the way down to the bottom, we can see that we have Jimmy. And Jimmy is basically the exact same as he was on the other machine. Now, let's say that I don't want Jimmy to use bin sh, because sh is just a regular shell. It's not bash. And bash has some very useful utilities. Then I can just go here, and I can change that to bin bash. If I write that out, and now if I log into Jimmy, now you can see that I have a bash shell. Well, Jimmy doesn't have a home directory, so I can't exactly go anywhere on Jimmy's user. But if Jimmy had a home directory, you could go there. Is there any other command that I need to demonstrate? Oh, right. Also, let's go over here, and if we ls-la banana.txt, who is the owner of banana? It says right there. Who's the owner of banana.txt? Yep, I'm the owner of banana.txt. Well, let's say I don't want to own that file anymore. Well, then I'm going to change the owner to Jimmy banana.txt. And now if I ls-la again, we can see that Jimmy owns banana.txt. Sounds good? Did I miss any commands? Alrighty. Does anybody have any quick questions? Because we are getting a little bit late. It's 12:45. Anybody have any questions about anything that we have shown today? All right. Well, in that case, I'd like to thank you very much for coming to today's general meeting. this Friday, we will be exploring some more in-depth topics about Linux. We will be discussing packages. Unfortunately, I won't have a million FedEx packages to give you guys. And we will also be exploring SSH. For those of you who know what SSH is, yeah. But if you don't know what SSH is, stay tuned for Friday and you'll find out.
Thank you.
Oh yeah, make sure to sign up for the interest form on the link tree. It's for Friday. Thank you. If you don't, you can't participate. What? Yes. Because we're doing the SDC stuff again. You want me to end screen share?